In this example, we're dealing with an airplane that starts from rest, so its initial velocity is 0. It accelerates at 2.3 meters per second squared, and it does so for a time of 28 seconds. And the question is, what's the displacement? Well, equation 219 relates displacement, velocity, acceleration, and time. Displacement is initial velocity times time plus 1/2 at squared. We don't know the displacement, that's what we're trying to figure out. But the initial velocity is 0, and the time is 28 seconds. The acceleration is 2.3 meters per second squared, and the time, once again, is 28 seconds. So we have an equation for delta x. All we have to do is evaluate it. 0 times 28 seconds is simply 0. If I square 28 seconds, I get 784 seconds squared. If I look at the units now, seconds squared cancels, leaving me with meters. That's good because we're looking for displacement, which should be expressed in meters. When I work out the numbers, I get 900. So the plane traveled a total of 900 meters down the runway. Now, of course, 900 is not the proper way to report this figure because of significant figures. Let's look at the original numbers I multiplied together. I multiplied 1/2, which is exact, times 2.3, which has two significant figures, times 28 seconds squared, which also has two significant figures. So my answer can have only two significant figures. The way I can report 900 to two significant figures is reported as 9.0 times 10 to the 2. Now, if you've been following significant figures all the way, you might think I've made a mistake here, because when I squared 28 seconds, I got 784 seconds squared. 28 has only two significant figures, so when I square it, the answer should have only two. That's true, but this is an intermediate step. I went ahead and kept all the digits because we usually don't round to significant figures till we get to the end of an equation. If we have to change rules, we also round before we change the rules. So if I go from addition or subtraction to multiplication, I'll have to round using the rules of addition and subtraction and then multiply. However, if we're always multiplying or always dividing, we wait until the end of the equation. So I waited until the end of the equation to deal with the significant figures. Now that's the proper way to do things, but when you do it that way, don't look at those intermediate steps. Go back to the original equation and see what numbers were originally being used. In the original equation, I was multiplying 2.3 by 28 squared. Each of those numbers had two significant figures, and that's why my answer can have only two.